All right, guys, so for this lecture, we're going to take a little bit of a look at the formation of blood cells, and the process is referred to as hematopoiesis. All right, so we're going to take a look at blood cell formation. All blood cell formation takes place in red marrow. All right, I know that we haven't covered the skeletal chapter yet, but there essentially is two types of marrow. There is red and yellow. Red marrow is all blood cell formation, and yellow marrow is all fat. Adults, for the most part, mostly have yellow. We've only got a couple spots in our body where we have red. Young kids have pretty much all red marrow up into a point. Usually about puberty is about the point where that kind of takes place. So red marrow shows up in most of our flat bones, so bones like our sternum, pelvis, and then also our scapulas. Short bones, we see a lot of that in, say, like the bones of your fingers. And then right at the epiphysis, which is the end of the bone, right here you can see of long bones. So like your femur and humerus, right up at the top, there's a lot of red marrow. And then down at the bottom there's also marrow. All right, all blood cells are derived from a specific common cell called a hemocytoblast. Sorry. Uh, Hard time pronouncing that this morning. So hemocytoblast is where they all kind of take off of. When we talk about red blood cells, the immature ones, when they first start out, are what are referred to as reticulocytes. And then they mature from there to be able to kind of obtain and hold oxygen. I'll post this link along with the lecture. That way you guys can kind of watch that on your own, but it shows that basic process of red blood cell formation. This just kind of shows how those all take off. So they all start off with this multi-point stem cell, right? And then from there, they can either divide and become a myeloid cell or a lymphatic cell. If they become a lymphatic cell, they become a lymphoblast. And then those are going to become the specific two types of white blood cells that we normally see in response to um, infection. So B cells as well as T cells. All right. The myeloid cell is the one that can divide and become most of our other ones. So it can become a erythroblast, which will eventually become an erythrocyte. It can become a megakaryoblast, which will become a megakaryocyte. Right. And then it can be a myeloid blast, which could end up being either one of the other types of white blood cells, the basos, the esos, and the neutrophils. Or it can be a monoblast, which eventually would become the largest of all those white blood cells, the monocytes. Okay. I don't think you're going to see an assessment question that's going to give you this kind of a chart, so it's just kind of for reference here. Fate of red blood cells. So they're actually unable to divide and grow on their own, so they have to continue to be reproduced by the red marrow. And because of that, they usually wear out in about 100 to 120 days. All right, so that's why we have to continually replace those red blood cells, and it's why it's important for people who to donate blood, because there are individuals that can't do that on their own. So we need to be able to kind of have a supply readily available for them. Once they're worn out, they actually get eliminated by phagocytes, and this is done in both the spleen as well as the liver. This is also why if somebody has like mono, which is a red blood cell disorder infection, their spleen becomes enlarged because their spleen is filtering out tons of those worn out but red blood cells or damaged red blood cells. So that's why it becomes an issue. The lost cells then have to be replaced by that division from those hemocytoblasts. Okay. Um, the rate of hematopoiesis is controlled by hormones, obviously, erythropoietin, right? These show up in the kidneys. We talked a little bit about that um, in the hormone chapter. So the kidney is responsible for producing that, and it's really actually in response to oxygen levels. So if we don't have enough oxygen in our system, the kidneys will actually start to produce this erythropoietin, causing those cells to start to divide and produce more red blood cells. This is the same basic process that happens to people that climb mountains. So the further up they go, the less oxygen is available in the atmosphere for them. So their body actually triggers this red blood cell formation as they climb, which is one of the reasons why they have to acclimatize. They have to climb up for a certain distance, wait a few days, and then they have to climb back down, and then they have to climb back up, climb back down. And every time they do that, their body makes red blood cells for them. If they did it all at once, their body would make way too many red blood cells, and they would actually end up very susceptible to things like blood clots. All right, so hemostasis, again, is maintained by negative feedback, and that's, again, specifically done by blood oxygen levels. So not enough, we're just going to produce more red blood cells, okay? All right, last slide here just shows that kind of imbalanced system. So normal oxygen levels, all right, we stay here nice and balanced. If we imbalance that, all right, we see this kind of cascade of effects that happen. So the kidney picks it up first. It triggers the release of erythropoietin. The erythropoietin specifically interacts with those cells in the red marrow of those bones, and then it causes the hematopoiesis to take place, and we start to produce these red blood cells. All right, we get enough red blood cells, then it kind of balances itself off, and then we end up kind of with this basic process of going back and forth. Okay, all right, we're going to stop there. Like I said, I'll post that video with the lecture as well as the basic PowerPoint as well. So